Hello everyone and a very warm welcome to this video lecture series in which we are talking about neural networks and deep learning. So in the previous video lecture, what we have seen is we have gone through all the computation and implementation inside the neural network, but we can see that that implementation was only limited up to a single training example. But in actual life, we have the training datasets that have m number of training examples. So in this video lecture, we are going to see that if we have m number of training examples in our data set, then how this computation inside the neural network is going to happen for all those m training example. Okay, because if we have m number of training example, then we need to stack up or compile a few vectors column wise so that we can have the computation, we can understand the computation of the whole neural network as a whole. Okay, so let us continue to watch this video lecture. Okay, now here is a very small neural network given to us, and we have some input features as x1, x2, and x3. We have this as a two-layer neural network. This is the input layer, this is the hidden layer, that is one hidden layer, and this is the output layer that is responsible for giving us the final output, the predicted output, that is y hat. Okay, and these are the equations that we have seen in the previous video lecture also. Okay, so we have this equation for z1, a1, z2, and a2. Okay, so if you are not familiar enough with how we have written these equations, so you can watch my previous video lecture. Okay, and there I have tried to explain all these equations in a very simple format. Okay, so now let us continue in this lecture. So what we can see here is basically if I have a neural network, so how can I use this neural network? As we have some input feature vector x, and using this input feature vector x, my task is I need to predict some output y hat. Okay, and this output y hat is basically termed as a2 in this context of this neural network. Okay, suppose this predicted outcome is called as a2. Okay, that is the final activation output. Okay, according to this example that we have considered in this video lecture. Okay, now this was the case when we were having a single training example, but what if now I have some m number of training example? So how, what is actually the representation that I can use to represent m number of inputs? Okay, and m number of outputs corresponding to m training example. Okay, so now let me write these representations. So I'll take the first training example as x of 1. Okay, now take into consideration that I am making the round brackets here. Okay, I'm not using the square brackets. Okay, because these representation are very important to us so that we could avoid confusions in further video lectures also. So this training example, that is the first training examples, gives us the output y hat of 1. Okay, so corresponding to the first training example, we have the output, predicted output y hat superscript 1. Okay, and if I want to write this output in terms of a, so I can write it as a square bracket 2 round bracket 1. Okay, so I hope this notation is clear to you. Now I'll take as second training example. Okay, so this would be represented as x2. Okay, so I'm applying this input x2 to my neural network, and this would give me the predicted output y hat round bracket 2. Okay, and if I want to represent it in the form of notation a, so this would be a square bracket 2 round bracket 2. Okay, I hope this is clear to you. And in further, suppose that if I have m number of training example, so what will be the notation for my mth training example? So it would be x round bracket m and my final output corresponding to this would be y hat of round bracket m. And in notation of a's, this would be written as a square bracket 2 and round bracket small m. Okay, so I hope this much is clear to you. And in order to create a general notation or a general representation for this of what we are writing here, we can define this as, suppose that if we are writing as a, and this square bracket, okay, this square bracket L basically represents the layer on which we are working, and this round bracket, inside this round bracket, if suppose that I write some variable I, okay, so this I will represent the example, okay, the ith training example that we are using in our training set. Okay, so this is basically the layer. Okay, and this I basically represents the ith training example. Okay, if you need to review this, what I have told you till now, you can pause the video lecture and you can review all the things that I have told you till now. Okay, because ultimately you need to remember these notations. Okay, now we have all these four equations. Okay, now we need to find a way in which we can represent this equation for all the m training examples now. Okay, so what is the way I can perform some operations so that I can represent all these four equations for m training examples? Okay, because these equations are written till now for only one training example. Okay, now I want to write this equation in some way so that I can represent this equation for m number of training example. Okay, so for simplicity and for better understanding, first of all, I'll try to write these all four equations using for loop in Python. Okay, and after that, if we have understood this representation in the Python programming language using for loops, then what we will do, we'll shift towards the vectorization concept. Okay, so after understanding this concept in for using for loop, we'll try to understand and we will implement all these four equations using the vectorization. Okay, so that would be a very easy way for you to understand. Now, suppose I have m number of training example, then my loop will start from I equal to 1, okay, from first training example, and it would go up to mth training example. So I'll write my loop as for I equal to 1 to m. Okay, this I have written the loop, for loop, and now I need to represent the equation z1, a1, z2, and a2 inside this for loop. So what my notation would be, now I need to write my notations corresponding to for all the m training example. Okay, so now I'll have to introduce the new superscript variable, that is the round brackets. Okay, the ith I inside the round bracket I have to introduce in these equations. Okay, so how I will write these, my notations would be z, okay, which I already write, z1 equals to w square bracket 1 x plus b1. Okay, this is the same equation. I have copied this equation here. And now I want to introduce the notation I for ith training example. So where I will introduce these notation, I'll introduce these notation for here. Okay. And another notation would be introduced to X. Okay. So I hope this much is clear to you. Now I want to write A also, so A1. So how I can write, firstly writing the same equation as a square bracket 1 equal to sigmoid function, and inside sigmoid function I need to pass the value of z as z square bracket 1. Okay, now what is this z? This z is coming from this equation. Okay, this output. Okay, so I need to apply this z over here. So what it is written here, z1 of I. So I'll again write z1 of I here, because this same is applied over here inside the sigmoid function, and this would ultimately give us the value of a1 of I. Okay, so till now what we have represented the value of z1 and a1. Now in the similar terms, we are going to represent the value of z2 and a2 also here. Okay, so let us do this. Okay, now inside the same for loop, I need to rewrite the value of z2 and a2. So the value of z2 would be z2 equals to w2 a1 plus b2. Okay, this is the same equation that is written over here, and now I need to put the i's here. So this one I will be represented here, and another I would be represented here. Okay, since we are writing it for ith training example. Okay, and then I need to represent a2 of I. So how this would be represented? There would be a sigmoid function, and inside the sigmoid function I need to write this, because ultimately this z2 would be applied over here inside the sigmoid function. So this would be z2 of I. Okay, so this is the for loop implementation for all these four equations for over to m number of training examples. Okay, now in the next slide we are going to see that instead of using this for loop, how can we actually implement this using the concept of vectorization. Okay, so let us continue over to the next slide. Okay, now I have clearly written over here all the four equations using the for loop. Okay, and using this pre-concept of this for loop, I need to represent these four equations, that is the dot product, using the vectorization concept. Okay, so let us continue. So what we have, firstly we have some input feature vector x. Okay, and now suppose we have this input feature vector x for only a single training example. So this I would represent it as x1. Okay, and I'll write the corresponding features of this first training example above and below here. Okay, now I'll write only this, and I'll create a vector if I have a single number of training example. But as we have seen in the starting of this video lecture series, that suppose I am having m number of training examples, so what is the method through which I can represent this input feature vector x? So I'll write x2 here, and corresponding to the second training example, I'll write all the features here. Similarly x3, and that goes on till xm. Okay, now closing this bracket. Okay, so this is my final input feature vector x for all the m training example. Okay, and suppose that for a single training example we are having nx number of features. Okay, so the dimension of this matrix would be nx comma m. Okay, so basically there would be nx number of rows, because there are nx features in each training example, and finally we have m number of training examples that are coincided or attached column wise, so we have m number of columns here. Okay, so I hope what is the significance of writing this dimension, this has been clearly understood over to you. Okay, now what I need to do, I also need to represent this equation in the vectorized form. Okay, so I need to have some capital representation of these small z small a's also, because already have the capital representation, that is the capital X, corresponding to these variable, that is xi. Okay, and corresponding to z and a also we need to have the capital representation. So what would be my capital representation corresponding to these? I can write these as z of square bracket 1 equal to w of 1 x plus b1. Okay, I hope this much is clearly understood over to you. And I'll write capital A of 1 equal to, now I'll apply the sigmoid function, and inside the sigmoid function I'll pass this value of z1 here. Okay, and similarly I need to write this for z2 and a2, that is corresponding to the second layer also. Okay, so I'll write z2 equal to w2. Now instead of writing x, this a1 would be applied as an input here plus b2. Okay, and my final activation function a2 would be equal to sigmoid of z2. Okay, I hope this much has been clearly understood. Okay, now what I need to do, I have represented capital X as the input feature vector corresponding to m training examples. Now I need to represent this z1 and z2 and a1 and capital A2, all these in the vectorized notation. Okay, so basically this z what we write is the vector corresponding to z11, z12, z13. Okay, so all the nodes corresponding to the layer 1. Okay, and if I write z2, then this vector z2 is made up of all the nodes, okay, corresponding to the second layer. Okay, so I'll represent it as z1 equal to z1 1 corresponding to the first training example, z1 2 corresponding to second training example, and I'll introduce all the z11, z12 corresponding to the first and the second training example above and below this. Okay, and suppose that if I have m number of training example, then what I will write, I'll write here as z square bracket 1 small m. Okay, so this is basically the vector representation of my z1. Okay, and now I need to have a vector representation of capital A1. Okay, so what would be my vector representation? It would be as A 1 1, A 1 2, and if I have m number of training example, then this would be A1 M corresponding to the mth training example. So finally, these are the capital Z1 and capital A1 that we have represented in the vector notation. Okay. Now, if you have any confusion regarding Z1 and A1, then you don't need to worry much about as of now, because in the next video lecture, we would be having a deep explanation as why we are actually using these representation in vectorized form to write these equations. Okay, so that is not a big problem here, but one trick is there as how you can understand, as how you can implement this z1 and a1 here, is that till now we have understood that we have this input feature vector x. Okay, and I have clearly told you that how are we writing this input feature vector x. Okay, so these are the small x's and this is the capital X. Okay, so you need to understand that actually how we are going from small x's to the capital X. Okay, and if you have this logic, then you can easily get that how we are actually moving from these small z's to this capital Z, and how actually we are moving from these small a's to capital A. Okay, we were having actually the training features, training set, training examples as a1 8 x1 x2 x3 that goes on till xm. Similarly, for each corresponding training example, we have z1 z1 z12 and that goes up to z1m. Okay, and stacking up all those column wise, okay, we have this capital notation as Z1 and A1. Okay, so I hope this much is clear over to you. If you have any confusions regarding this notation, then you don't need to worry, because in the next video lecture we are going to have a deep explanation as exactly why we are writing these notations. Okay, so don't forget to watch my next video lecture. I hope this video lecture would have been very much informative to you. If you have any doubt corresponding to this video lecture, then firstly watch my next video lecture, and then again if you are having any doubt, then you can write in the comment section. There is a Google form uploaded in the description of this video. You can fill this form. Okay, so I'll definitely be replying over to you. And if your friends are working in this field of neural networks and deep learning, then don't forget to share my video lectures with them also. Like my YouTube videos, subscribe to my YouTube channel, so that as soon as a new video is uploaded, it would be forwarded to you in the form of a notification. And thank you so much.